Good day, students. Today, I want to talk on a topic titled Total Internal Reflection. Total internal reflection is the reflection of an incident ray of light at the interface between the medium of incidence and the medium of lower refractive index, when the angle of incidence in the denser medium exceeds the critical angle. What is critical angle? Critical angle is the angle of incidence in the denser medium when the angle of refraction in the less dense medium is 90 degrees. The two conditions that makes total internal reflection to occur is as follows. 1. Light must be traveling from an optically more dense medium to an optically less dense medium. The second condition is that the angle of incidence in the denser medium must be greater than the critical angle. Now, from Snell's law, from Snell's law, we know that refractive index equals sine I over sine R. Now, let's see. This is glass, this is air. Light incident ray comes in, this is the weak reflected ray and refracted ray. The angle of incidence is equal to the angle of reflection. That's why I put it as II, to show that if this is 20, this also will be 20. At this point, we have the critical angle. This incident angle is increasing. When it increases to the critical angle, you have the refracted angle to be 90 degrees. The refracted ray moves at this point on the glass and makes the angle to be 90 degrees. At that point, we have the critical angle. We still have weak reflected ray, but it has increased to the critical angle. The critical angle here and also critical angle, it increases at the same rate. But here we have total internal reflection. It has increased from critical angle to this angle. At this point, we have the total internal reflection. There's no refraction. This refracted ray has moved up and replaced the weak reflected ray. It has become strong reflected ray at this point. There's no refraction. Now, when you are defining total internal reflection, it shows with these three diagrams. That means that from here, there's no total reflection, there's no total internal reflection. Here, we have a critical angle that's increased to critical angle. At that point, we have to show that the refracted angle is 90 degrees at this point. And this is the less dense medium, this is the denser medium, this is the more dense medium. And at this point, we have the total internal reflection, no refraction. We have strong reflected ray. Okay, now since we're having critical angle at this point, you have sine, change it from incident angle to C, critical angle. At that point, we have sine 90 degrees, which is equal to, it's moving from glass to air, use G and A. That is, ray of light is moving from glass to air. With our principle of reversibility, introduce 1 over, let A comes to the front, and G still the same, which is equal to 1 over N. Okay, now sine C equals sine 90 is 1 equals to 1 over N. You cross multiply. You have N sine C equals to 1. You divide both sides by N if you have to look for critical angle. Now you have N sine c over n equals 1 over n. N cancel n. Sine c equals 1 over n. When you are looking for the critical angle, which is c, you now have c equals to sine inverse of 1 over n. At this point, you will be given the refractive index. You are given as 1.5. You put 1.1 divided by 1.5, whatever you get, find the sine inverse of the value. Second function sine give you the sine inverse. You get your critical angle in degree. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.